A stem and leaf plot uses a stem number and a leaf number to represent data. The data is shown in two parts, the stem and the leaf, and there always should be a key that shows you what this means, and I'll show you why that's important. So in this case, 2 as the stem and 4 as the leaf, that means 24. Okay, so that's what that means, and it's a really good way to show lots of data in groups. The graph is similar to a histogram, right? On its side, so you kind of flip it around. It could look a bit like a histogram with class intervals, but there is no loss of detail of the original data. So we know exactly what the data is, and imagine that sideways as a histogram, like as a bar graph. We can do back-to-back stem and leaf plots. So as you are getting away this way, you're spreading out and getting from smaller to larger numbers. So in this case, the stem can be 2 digits, and that represents 109. So 109. This would be 110. This would be 119. So as you see, as we're getting away from the stem, either going left or right, our numbers are slowly increasing. Data can also be symmetrical, which is, if you flipped it up on its side, you can see that this data is more symmetrical because it's sort of that shape. Most of the data points are in the middle, fall in the middle, or it can be skewed, where it's like this, and we don't have an even spread of data. We have lots more toward one end or the other. So now we've got lots of data, and we want to first organize this into an ordered stem and leaf plot. So as we'll look up here, we only need a stem and a leaf on one side. So our stem can go here, and we want to have a look at what we need for a stem, because most of the data that we see actually has a decimal point in there. So let's see, the first one that I can see is 0. I don't know if that's the very first one on the list. And if I scan through this, the highest one that I'm going to see is 7. So I can go ahead 1. And then I can put my key in the right place. My key, I don't need the right key. I need to write 0, whatever it is. It could be absolutely any of them. Means 0.3. And now I'm going to painstakingly go through this data and make sure that I get them in order. So 0.3 is not actually my smallest datum, it's this one. So 0, 1 means, according to our key, 0.1. So I've got that one. Now I look and see, and there is another one, 0.1. So I just put another leaf in there. Probably should spread them out a little bit just to make sure that they're not confused. Then I'm going to say my next one is 0.3. And so that's what the beginning of my stem and leaf plot. Remembering that that key tells us it's not 1 or 3, it's 0.3. And I'm crossing them off as I go, and now I'm going to find the rest up. The next one I'm going to find is, got a 1 as its stem. There we go, 1.0, that has to be the smallest one. And then, is there another one of those? 1.0 has to be the smallest one. So now I'm going to go through, and I'm going to get them in order. I can always fix it if I make a mistake, but I'm going to get them in order from smallest to largest. Okay. Whew. Painstaking. I think it looks like I've got them all. And so now we've got them arranged into our ordered stem and leaf plot. Now we got to find the median. So the median, so notice that I wrote a lot of these the same. So I'm going to make you prettier. I've got 4 and I've got 1 and 1 and 1. That means that I have 4.1, 4.1, 4.1 several times. So I need to count every single one of those. 0.1 is my first, 0.1 is my second piece of data. So I'm going to count my way through, and I'm going to tell you that I have a total of 28 values. So if I'm counting my way through here, I'm going to count each of these points as 1 of the 28, so I can find my middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now that's halfway through 28, so there's a 3.3 there. But that's not my median. So if I start from the other end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I'm going to get also 3.4. So you remember when we have an even number of values, we're going to find the average of those two, sorry to say the mean of those two. So the median equals 3.35, halfway between those two. So our median is 3.35. The mode, remember, is the most. So the one that appears the most is going to be this set there, because we see 4.1 happening 1, 2, 3 times. There are some other ones that happen frequently, but not with the same frequency. So the mode is 4.1, and then we're going to describe, is this data symmetrical or is it skewed? I think it's never going to be perfect, but we're near enough having it symmetrically. We would say it's the distribution of numbers is approximately symmetrical about the stem containing the median. So closest to that measure of center. Shop owner has 2 gene shops. So now we have to do a back-to-back stem and leaf plot because we've got 2 shops. He's got 2 gene shops. The daily sales in each shop over a 16-day period are recorded as follows. We're going to draw a back-to-back stem and leaf plot with an interval of 10. That just means that each line is going to go up to 10. Compare and comment on the differences between the sales made by the 2 shops. So our stem is going to go in the middle. So we're going to get a big old line like that. Here's our stem. How many? We don't have any more than 2 digits, so our stem will be a single digit. And then our leaves will go on one side. We'll call that shop A, and we'll call this one shop B. And then again, we've got to painstakingly go through, and we've got to sort out the order. We do need a 0 because we have single digits. So in shop A, they put them in order for us. Oh, bless. So let's do shop A first because it's going to be the weird one. Shop A, the first number is 3. So I represent didn't put my key on, did I? The key down the bottom, 1 blank 3 means 13. Not a decimal this time. Means a whole number. So in this case, shop A, we're going to go out to the left. So starting from nothing, 0, 3, that's our first one. And that's the only one that shop A's got. While we stay on that same one, there's a lot of single digits in shop B. So the first one would be 4. So 0, 4. Leaving a little bit of space so we can line them up nice. 6. Another 6. Wow. Interesting. Okay, so we've got heaps of single digits in shop B. I wonder if that'll be interesting later. I expect it will be. And so we've exhausted all those, and so our next stem is all the ones that start with 1. And lots of them, there's lots of them in each side, so I'll start again with shop A. Remembering that we're going left, our numbers are getting larger from right to left, which is a little bit strange, but that's how it is. Okay, I think I got all of the single digits, and notice that they do line up. They should line up really neatly vertically, but they don't have to line up number under number. They just need to be ascending. So it's okay that we have a 4 over a 0 in this case. And then my last lot is here with a stem of 2. Let's go ahead and be rebels and go 27 and finish off shop B. And oh dear, shop A has got lots of stem 2s. All right, it's sloppy. You'll use a ruler for yours, of course. So now we've got a back-to-back stem and leaf plot with an interval of 10. Compare and comment on the differences between the sales made by the 2 shops. So we'll look at both sides, and if we look at shop A, it has a higher number of daily sales. So what was this? 2 gene shops over a 6-day. This is the daily sales over each of these 16 days. So shop A has a higher number of sales because they have more in that column that has a stem 2. Sales are generally between 12 and 28. So there's that one little outlier at 3. That one day of very low sales. Whereas shop B, Sales are generally between 4 and, would you say 17-ish? Yeah, 17, that's that. So that's where the bulk of theirs is, with only one high day of sale at 27.